Chapter 7, Number 20. A 9.50 kilogram has a speed of 1.30 kilometers per second. What is the kinetic energy in joules? Then what is the bullet's kinetic energy if its speed is halved? And what if its speed is doubled? And for part B and C, we're going to answer them quickly and then confirm them with a longer calculation. But for real, the short answer is what I really want you to understand, but I want to prove it to you. Alright, so part A is largely an annoying conversion thing. The kinetic energy is 1/2 the mass times the speed squared, which is 1/2 times, and I have a 9.50 grams bullet, and then I've got to say, oh, but every 1,000 grams is 1 kilogram. That way I'll get in joules, which is what I want. And then here I'm going to have 1.30 kilometers per second, and I want to have meters per second, so I'm going to say, oh, well, every kilometer is 1,000 meters. And I have to remember that in the equation, it's all squared. So we just kind of throw that into our calculators to get 8,027.5 joules. And based on the fact that we have three sig figs here and 3 sig figs here, I should end up with 3 sig figs up here, which is 830 joules. And then part B and C are meant to be, or it can be done kind of quickly, because of the fact that we have the square here. Whatever we do to velocity, the square of that gets done to kinetic energy. In other words, if we replace v with, part B, it's a half v, that's the same as saying that the kinetic energy goes to 1/2 squared of the original kinetic energy, or 1/4. Alright, so having the velocity makes the kinetic energy only 1/4 as large. And just to be clear about it, we probably should prove that so that in the future you don't have to. So we'll have the same kind of thing. We'll have a half and then 9.50 grams times 1 kilogram per 1,000 grams. And that's not going to change. And now we'll have 0.65 kilometers per second times the same 1,000 meters per kilometer, all squared. And on the calculator, that comes out to be 2,006.875 joules, which rounded to 3 digits is 2010 joules, which we see is basically 1/4 of 80/30. At least, again, if you were to round to the right number of sig figs, since this 80/30 over 4 is 2007.5, which rounds to 2010. And exactly the same sort of thinking is going to give us part C. We're going to say that if we change the velocity and we make it twice as large, that has the same impact as taking the kinetic energy and making it twice squared as large, or 4 times as large. So if we kind of just compute the kinetic energy with the same kind of thing, so 1/2 times 9.50 grams times 1 kilogram per 1,000 grams times, and now we have to double this, so we'll have 2.6 meters per second, or kilometers per second, times 1,000 meters per kilometer, again all squared, and we throw that into a calculator. What we get is 32110 joules, which is 32,100 joules. And if we take 8030 and multiply by 4, we get the same thing, right? So we get, to be explicit here, if we take 4 times the original kinetic energy, we get 32,120, which when we round it is the same. So the rounding, just to show sig figs sort of respects this, but the rounding is sort of extra. So the key thing moving forward is that you would never have to actually do the computations in B and C. You could just say, oh, if I double the speed, I quadruple the kinetic energy, and save yourself a little bit of grief.